The death of the KV cache. Liquid AI's LFM-2 1.2b model runs a full 32,000 token context in just 719 megabytes of RAM, roughly 30% less than a similarly sized Llama instance. This isn't the result of standard 4-bit quantization or heavy context pruning. Instead, the architecture replaces the majority of the transformer's memory-heavy attention heads with gated short convolutions. By decoupling sequence length from the traditional growth curve of the key-value cache, these models allow for long context reasoning on edge hardware that was previously limited to basic completion tasks. Hybrid backbones and Neural ODEs. The core mechanism in the LFM-2 family is a hybrid backbone, where only 1 out of every 4 layers uses grouped query attention. The other 30 layers utilize multiplicative gates and structured adaptive operators derived from liquid time constant networks. Think of it as a signal processing system rather than a pure token predictor. The convolutional blocks act as fast, localized filters that handle the bulk of the sequence processing, while the sparse attention layers are reserved for global context. This hardware-in-the-loop design targets the specific memory bottlenecks of the transformer, achieving 200% higher throughput on consumer CPUs without sacrificing score parity on benchmarks like IF-eval. The scaling cost of sparsity. The recent release of the 24 billion parameter mixture of experts variant shows how this hybrid approach scales to frontier levels. Despite the total parameter count, the A2B model activates only 2.3 billion parameters per token, an aggressive sparsity ratio of less than 10%. However, this architectural efficiency introduces a significant training hurdle. These models require roughly 3 times the initial compute to reach convergence compared to vanilla transformers of the same active size. While the LFM 2.5 thinking variant has closed the reasoning gap on math benchmarks, the dependency on custom CUDA kernels for the convolution blocks remains a friction point for broader developer adoption compared to the standard matrix math of the transformer. The Architecture of Inevitability. LFM-2 indicates that the transformer's reign as the universal architecture is ending because of hard physical limits in edge deployment rather than a lack of intelligence. By moving from the quadratic scaling of the attention mechanism described in our architecture deep dive to the hybrid gated convolutions seen in the 24 billion parameter model, Liquid AI has proven that the memory bottleneck is an engineering choice, not a law of physics. For builders, this shifts the optimization target from maximizing tokens per second on an H100 to maximizing intelligence per watt on a standard mobile processor. We are entering an era of heterogeneous AI, where the heavy lifting of context ingestion is offloaded to liquid operators, leaving the transformer to act as a high-precision reasoning engine only when the attention mechanism is strictly necessary. The real indicator to watch is the adoption of the LFM 2.5 audio models in the automotive sector later this year. If these models maintain sub-20 millisecond latency in real-world environments, the economic justification for cloud-dependent edge agents will effectively evaporate. Watch for the release of optimized Triton kernels for liquid operators as the next major performance jump. Subscribe for more,